Hello everyone, welcome to my channel. In the previous video I spoke about how to use Cramer's rule to solve a system of two linear equations in two unknowns. In this video I want to continue with Cramer's rule, but I'm looking at a system of three equations in three unknowns, all of them being linear. So let's look at the first one then. We have we're supposed to solve x minus y plus 2z equals 4, 2x plus y plus z equals 2, and minus 2x minus 3y plus 4z equals 5. And then we have the second one. So let's look at how we apply Cramer's rule in determining the solution to these equations here. So let's look at number one. I'm just going to capture that. Let's call this page 1. Number 1, what we have is x minus y plus 2z equals 4. The other one is 2x plus y plus z is equal to 2. And then the last one is minus 2x minus 3y plus 4z equals 5. Now, like I said last time, rewriting these equations in one matrix equation, it's going to be as follows. We have here the coefficient matrix. Talking about coefficients of x, y, and z, we have 1, 2, and minus 2 in the first column. 1, 2, and minus 2. Moving on to the next column, the second one, it's going to be minus 1, 1, minus 3. So minus 1, and then we have 1, and then minus 3. And then finally, the third column is going to be 2, 1, 4. 2, 1, 4. And then we have our matrix of unknowns, x, y, z. And then at the end there, our matrix of solutions or numbers on the right-hand side of the equation. That's 4, 2, and 5. So this is what we get from these three equations. Now, remember what I said last time? If we want to determine the value of x, which is going to be our first unknown to determine here, we take these values. They must replace the coefficients of x in the numerator expression for the value of x. So we are going to say now, therefore, x is going to be equal to the determinant of replacing these numbers with these numbers, 4, 2, 5, and the rest of them must remain exactly how they are. Minus 1, 1, minus 3, and then 2, 1, 4. The determinant of that divided by the determinant of the coefficient matrix, which is this one here. So we're dividing that by the determinant of 1, 2 minus 2, and then minus 1, 1, and then minus 3, and finally 2, 1, 4. Now, these are 3 by 3 matrices, 3 rows and 3 columns. Now, how we determine the determinant of a 3 by 3 matrix is as follows. So I'm going to say here, therefore, numerator is going to be equal to, remember the numerator is the determinant of 4, 2, 5, 4, 2, 5, and then minus 1, 1, minus 3, minus 1, 1, minus 3, and then 2 and 4. 2, 1, 4. Now here's how it works. Here is how it works. So the first number I'm focusing on is 4. But the sign of 4 will be as follows. So this is going to be equal to, I take minus 1, and then I'm in row 1, column 1. So plus the power 1 plus 1. And then I have my 4. It has to be multiplied by, I consider 4. It means I'm going to avoid these numbers and those numbers. I'm going to focus on these ones. So it's 4, and I'm looking at the determinant of 1, 1 minus 3, 4. So 1, 1 minus 3, 4. And then plus, again, I'm using the same, following the same part here, this part here, minus 1. But now I'm focusing on minus 1. Remember, from 4 you go to minus 1, and then you end up at 2. Or you can go down here, but I like to take numbers in the first row. So 4, and then I have the sign there, minus 1, 1 plus 1. And then the next part is going to be minus 1, this one. And then here now I'm in still row 1 but column 2. So 1 plus 2. First number is for rows in terms of the power, and then we're adding to the number of columns. And then I have minus 1. Remember, like I did with with 4, positive 4 here, I have minus 1. Now this time I have to multiply that by the determinant of minus 1. I'm at minus 1. I ignore these numbers and those numbers. I'm going to take this one and that one and this one and that one. So that's 2, 5, and then I have 1, 4. And finally, the last part is going to be plus. I repeat this, minus 1. This time I'm still in row 1 but column 3. And then what am I focusing on? The number 2. And then I'm going to look at the determinant. I ignore those numbers. I focus on the numbers that are not in the in the row and column in which this number is. This is basically what we're saying here. If you take 4, you avoid numbers that are in the same row and the same column. If you take minus 1, you avoid numbers that are in the same row and the same column. Take 2, avoid numbers in the same row and same column. So you're going to focus only on 2, 5, 1, minus 3. So this is going to be multiplied by the determinant of 2, 5, and then 1, and then minus 3. Right. So let's work on this expression then. Going to page number 2. Here, page 2. Let me call this page 2. And then we do as follows. Let me move this one down a little bit. Right. So now the first part, minus 1 to the power 2 is 1 times 4 is 4. And then remember these ones here, right diagonal, product on the right, elements on the right diagonal minus product of elements on the left diagonal. So 1 times 4 is 4, minus 3 times 1 is minus 3. And then I have that plus, because this is minus 1 to the power 3 is minus 1 times 1 is 1. That's why I was saying plus 1. And then I'm going to say that's product of 2 and 4, 8 minus 5, 8 minus 5. And then I'm coming here and I'm going to say this is positive 1 because 1 minus 1 to the power 4 is 1 times 2 is positive 2. And then here I'm going to say minus 6. 2 times minus 3 is minus 6. Then minus 5 times 1 is minus 5, like so. Right, let's simplify this now. This is 7, 4 times 7, and then plus, this is basically 3 times 1 is 3, and then minus, because that will be minus 11 times 2 is minus 22. Right, so this is 28 plus 3 minus 22, and that will be 31 minus 22, and the answer is 9. Right, so that's our numerator. Let's work out the denominator. Remember, the denominator is the determinant of the coefficient matrix, which is 1, 2, minus 2, and then minus 1, 1, minus 3, 2, 1, 4. Right, we repeat the same procedure. So now I'm going to say denominator. The denominator is equal to the determinant of, check this out, determinant of 1, 2 minus 2. Hope you can see it there. Here you can. 1, here is what we're talking about, 2 minus 2, and then we have minus 1, 1, and then minus 3, and then 2, 1, 4, like this. Now, let me put this away. What are we going to say here? The same procedure, minus 1, cofactor, some people call it. The power, first column, first row, first column, so 1 plus 1. And then the number we're focusing on is 1. This one. Remember, this is the one we're focusing on, that one. That's the one. But the sign will be obtained by raising minus 1 to the power, the number of rows plus number of columns in which that number is. Right, and then we're multiplying by the determinant of, remember we ignore numbers in which this one is, number of, we ignore elements that are in the same row or column with this number. So we're ignoring those, and these we're focusing only on these ones here. So we're going to say 1 minus 3 and then 1, 4. And then we're repeating the same procedure, minus 1 to the power. Remember, we're in column 1, but now in row 1, but now we're in column 2. And the number of focus is minus 1. This is our number of focus, minus 1. And then we multiply that by the determinant of 2, 1, minus 2, 4. 2, 1, minus 2, 4. and then finally plus. We're repeating the same procedure. We are still in row 1, but now we're in column number 3. There, we're in row 1, but column number 3. And then our number of focus is 2, and then we ignore those numbers, and we focus on these ones. Times 2 minus 2, and then 1 minus 3. Right, let's do the calculations. This is positive 1, so we have 1 now. Multiply by, that's 4. 4 times 1 is 4, minus 3 times that. Remember, it's going to be minus 3, so it's going to be positive 3. Right, and here that's minus 1 times minus 1 is positive 1. And then here this is 8 minus 2, it's going to be plus 2. And then we are here now. This is positive 1 times 2 is positive 2, and then this is minus 6, and then minus 2 is going to be plus 2. Right, let's simplify this. This is 7 plus, and that's 10, and then minus, because that's minus 4 times 2 is minus 8. And this, when your maths, is 17 minus 8, and the answer is 9. And we're saying the numerator is 9. There is our numerator. The denominator is 9. Therefore, value of x is going to be numerator divided by the denominator, and the answer is 1. So get the value of x now. Let's move on to the value of y. We're doing the same process. But remember now, page 3 is where we're going at now. Page 3. Remember now, we want to find the value of y this time. So these numbers, coefficients of y will be replaced by those. But we keep these ones and those ones constant or the same. And then the denominator will still be the determinant of the coefficient matrix, which will remain the same value we obtained as 9. It will remain this value here. The denominator will remain positive 9. Hope you can see it there. Yeah, you can. All right, let's look at the value of y now. We're saying y is equal to the determinant of, remember what I said? I said these will remain as they are. 1, 2, minus 2. 1, 2, minus 2. But the values of y, coefficient of y will be replaced by 4, 2, and 5. That's 4, 2, and 5. And then the last numbers will remain unchanged. 4, 2, and 5 we've taken the place of those numbers, and then 2, 1, 4 must remain the same. 2, 1, 4 must remain the same. And then we're dividing this by the determinant of the coefficient matrix, which is basically we obtain the answer as 4. As 9. Let's look at the numerator now. Numerator will be equal to, if I go straight into working out the determinant, minus 1, row 1 plus column 1, and we're focusing on the number 1, that number there, multiplied by the determinant of 2, 5, 2, 5, 1, 4, 1, 4, and then plus minus 1. We're still in row 1, but we're now in column number 2. Our number of focus is 4, and then we're multiplying that by the determinant of 2, 1 minus 2, 4. 2, 1 minus 2, 4. And then finally, plus. We repeat the same process. We're still in row 1, but now we're in column number 3, and our number of focus is 2. That's our number of focus. There it is. Multiply by the determinant of, ignore those numbers. We're focusing on 2, 2 minus 2, 5. 2, 2 minus 2, 5. Right, now let's evaluate this. So what do we have? There it's going to be 1 times, that's 8 minus 5 times 1 is 5. 8 minus 5. All right. And then that's minus now. Minus 1 times 4 is minus 4. And then this is 8. 2 times 4 is 8 minus 2, which is going to be plus 2. Because minus 2 times 1 is minus 2. And then when we subtract, it's going to be plus. Right. And then we end up with this one here. Minus 1 to the power 4 is positive 1. Times 2 is positive 2. And then multiply by 10. Minus 2 times 2 is minus 4. So we're saying minus 4. Like that. So this is going to be 3. And then this is 10 times 4 is minus 40. And then this is going to be plus 2 times, that's 14. 14. So this is 3 minus 40 plus 28. And the answer is 31 minus 40, because 3 plus 28 is 31. The answer is minus 9. And therefore, we can say, therefore, y is equal to, the numerator is minus 9, the denominator is 9, and our answer is minus 1, right? Next, we end up with z. The value of z is obtained in a similar fashion. Now moving to page number 4. Let me put these papers aside. Page 4. Remember this time, let me take some of these pages here. This time, we're going to replace these numbers, which are coefficients of y, these numbers, by those numbers. We keep these ones just like that. And the denominator still remains the determinant of the coefficient matrix. All right. So now what are we saying? We're saying, let me put this one up, and I'm going to say z is going to be equal to the determinant of, like I said, these stay the same, but those must be changed, placed by these ones. So 1, 2 minus 2, and then we have minus 1, and then we have 1 minus 3, and then we replace those numbers at the end there by 4, 2, 5. We're dividing this by the determinant of the quotient matrix, which is a 9 as the determinant of the coefficient matrix. Let's go on the numerator. So we're going to say numerator will be equal to, if I go straight, minus 1 when row 1 plus column 1. I'm focusing on that one there. Our number of focus is 1, and then our determinant is going to be involving 1 minus 3, 2, 5. Right, and then plus minus 1. We're still in row 1, but column 2, our number of focus is minus 1. Remember, we're here now. We're still in row 1, column 2, number of focus is minus 1. Determinant will be 2, 2, minus 2, 5. 2, 2, minus 2, 5. Right, and then finally plus. We're still focusing on row 1, but now we're in column number 3. Our number of focus is now 4. We're multiplying that by the determinant of 2, 1, minus 2, minus 3. 2, 1, minus 2, minus 3. Right, that 3 doesn't look very nice. Just want to clean up a little bit. Yeah, like that. Right. So now let's look at, I just want to make sure these numbers are not too close together. Otherwise, one would think that it's minus. Those numbers would not easily notice the difference there when the numbers are too close together. It would not look like a matrix. I mean, yeah, a rectangular array of numbers. Now let's go on. So what are we talking about? This is 1 times 1 is 1, and then we're saying 5 times 1 is 5, and then we have minus 6, which is just plus 6, and then this is minus 1 times minus 1 is positive 1, and then we have 10 minus 4 is 10 plus 4, and then we have here now, this is positive 1 times 4 is positive 4, and then we're saying minus 6, minus 2 times 2 times minus 3 is minus 6, and then minus 2 is going to be plus 2. Right, so this is 11 times 1 is 11, plus 14 times 1 is 14, and then here we have minus 4 times 2 is minus 16. Remember, minus 4, positive 4 times minus 2 here. Oh, this is minus 4, so minus 4 times positive 4 is minus 16. I'm correct. Right, let's carry on. So this is going to be 25. 11 plus 14 is 25 minus 16. The answer is 9. Right, so we can say therefore our z is going to be equal to numerator 9. Our denominator, remember, we worked it out already, and our final answer is 1. So we can say here now, therefore x equals 1, y equals, we found it as minus 1, and z, we found it as 1. So this is our final solution by using Cramer's rule, right, involving the determinant of a 3 by 3 matrix. Let's repeat the process for a system number 2. Naturally, that should have been fine. This will take about, again, another 19 minutes. I think I'm going to stop here. I'm going to bring up this one in another video, basically to repeat the same process, because otherwise the video would be too long. All right, if you're new to the channel, please support us by subscribing. My voice is a little bit low because of a little flu attack, but I will be fine. All right, I'll see you in the next video.